Hi, welcome to Tesla Car World. You may or may not have noticed, but the Tesla Semi is the only Tesla vehicle that doesn't have a dedicated production line. In the past, manufacturing the Tesla Semi relied mostly on manual assembly lines, with very few specialized machines capable of producing parts for large trucks like big rigs. This has been one of the biggest bottlenecks, which explains why there are fewer than 1,000 Tesla Semis on the market today, even though it's been nearly 8 years since its debut. People often joke that building the Semi is truly production hell. The lack of scale and advanced automated manufacturing technology has been the main reason Tesla has struggled to meet the growing demand in the trucking industry. Now, Tesla has addressed the scaling issue with a brand new 4 million square foot factory dedicated to Semi production. But, clearly, a proper production line is still missing. However, a major turning point just happened. Drone footage from Zanigler, the Tesla Semi advocate, captured the moment a massive press machine was transported from Giga, Texas to Giga, Nevada, using 2 trucks and 3 trailers. This was not only an impressive logistical feat, but also a clear sign that Tesla is preparing to change the game with a Giga press built specifically for semi-truck production. With the arrival of this machine, the goal of producing a Semi every 10 minutes, an ambition that could help Tesla reach Elon Musk's target of 50,000 trucks per year, now seems more achievable than ever. So how exactly will a Tesla Semi be built? Could this be the key for Tesla to conquer the global trucking industry? Let's find out. Have you ever wondered why Tesla has never used a die-casting machine for semi-trucks? Currently, Tesla only uses the Gigapress to manufacture models like the Model Y, Cybertruck, and Cybercab, casting the front or rear underbody in a single piece instead of assembling dozens, or even hundreds, of smaller parts through welding, bolting, or gluing as in traditional methods. However, the Tesla Semi is a heavy-duty truck with far greater dimension and weight compared to the Model Y or Cybertruck. Its frame must withstand massive loads and harsh operating conditions, requiring different designs and materials. The existing Tesla Giga press machines, with clamping forces ranging from 6,200 to 9,100 tons, may not be large enough or optimized to cast the bigger, more complex components needed for a heavy-duty truck. Furthermore, developing a larger Giga press would require a bigger factory footprint, which is why Tesla hasn't used die casting for the Semi until now. However, according to Sawyer Merritt, citing video footage captured by Zangler, he wrote on X, Tesla has just taken delivery of a very big and heavy package at their new semi-truck production facility in Nevada. It appears like it could be a stamping press for the Tesla Semi. It took 2 semi-trucks and a triple trailer to move it. Tesla Semi production is expected to start in the coming months. The truth is, we usually only see the final product, the sleek Tesla Semi, but rarely think about the massive machines required to build it. The fact that it takes 2 trucks and a triple trailer just to move a single piece of factory equipment is a powerful reminder of the incredible engineering and logistics happening behind the scenes. This isn't just about building a truck, it's about building the machine that builds another machine. And you know what? The Tesla Semi is unlike any other electric truck in the world. Just look at it. 500 miles of range, 80% charge in 30 minutes, 0 to 60 miles per hour acceleration in 20 seconds, the ability to haul a gross weight of 82,000 pounds, energy consumption of 1.7 kilowatt hours per mile, or even 1.55 kilowatt hours per mile in the latest performance figures, and many more specs. Clearly, no other electric truck in the world can compare to the Tesla Semi, because from the very beginning, it was designed and built in a completely different way.
We were really inspired by the high-speed trains.
Yeah.
We've been to Japan, the Shinkansen, where this really kind of super aerodynamic train, just for obviously efficiency at high speed. So that was a big inspiration for this.
Tesla's chief designer, Franz von Holzhausen, has revealed a lot about how the semi-trucks are built. He emphasized that the Tesla team isn't constrained by the traditional designs of internal combustion engine trucks. They don't need a central gearbox or a large front engine, which allows them to completely rethink the truck's layout. This opens the door to creating a truck that is not only efficient, but also more comfortable and safer. Tesla engineers spent time talking to many truck drivers and realized that the cab is essentially their office, where they spend hours every day. As a result, the design focuses on comfort, turning the Tesla Semi into an ideal workspace, a complete departure from conventional truck cabins. One of the most striking features of the Tesla Semi is its aerodynamic design. The truck draws inspiration from Japan's Shinkansen high-speed trains, with a bullet or teardrop-like shape to minimize air resistance. Its drag coefficient is only about 0.4, nearly twice as efficient as traditional diesel trucks, which usually range between 0.8 and 0.9. This means the Tesla Semi doesn't push against a wall of air like older trucks. Instead, it slices smoothly through it. The Aerodynamics team invested heavily in optimization, including a flat underbody without protruding exhaust systems or large drive shafts. They used detailed wind tunnel models to simulate headwinds, crosswinds, and interactions with trailers, ensuring the entire system operates efficiently. The result? The Semi consumes less energy, extends its range, and lowers operating costs, a crucial factor considering trucks account for 12% of fuel consumption in the U.S. From a technical standpoint, the Tesla Semi emphasizes safety and ease of drive. That's why most feedback from PepsiCo drivers indicates that the Semi is much easier to drive than they expected. Without a gearbox, driving becomes as simple as piloting an electric car. The driver sits in a central position, providing a panoramic view of the road and surroundings, reducing blind spots. The interior is spacious, featuring a steering wheel and 2 large screens to control all functions, along with a small storage compartment in the front, similar to other Tesla models. Safety is enhanced by a low center of gravity reducing rollover risk, an active control system that prevents jackknifing and nearly wear-free brakes. The truck also comes with blast-resistant glass and advanced autopilot features. Because there aren't many strict safety regulations for trucks, Tesla applied the high standards from its other vehicles, effectively making the Semi the safest truck ever built. Technical performance is another standout feature. The Semi uses 3 independent rear-wheel motors, delivering around 1,500 system horsepower, but tuned to prioritize durability and efficiency. It doesn't have all-wheel drive. Instead, it focuses on the 2 tandem drive axles, which helps extend tire life, a major cost in the trucking industry. The steer tires aren't subjected to torque, so they wear more slowly, according to regulations. The truck has 2 different gear ratios, one for high-speed efficiency, cruising axle, and one for high torque axle, allowing 0 to 60 miles per hour acceleration in 5 seconds when unloaded, or 20 seconds when hauling 80,000 pounds. At startup, all drive wheels are engaged. Then it switches to a stable mode to save energy. Many components are borrowed from other Tesla platforms, such as carbon-wrapped rotors from the Model S Plaid or drive inverters from the Cybertruck, leveraging Tesla's proven experience and reliability. At first glance, most of us might think the semi-truck sits lower than a traditional truck. However, that's really just an optical illusion. The steps are designed lower to make it easier for drivers to climb in. The floor height is actually comparable to a conventional truck, but Tesla has broken the steps into smaller increments to reduce strain when getting in and out, which is the leading cause of workplace accidents in the trucking industry. The ground clearance of the Semi is also similar to other trucks, but Tesla has optimized entry and exit for both safety and efficiency. So, does the air suspension adjust? Yes, Tesla Semi is confirmed to have adjustable air suspension, which is very useful when connecting to trailers of different heights or when navigating obstacles. Additionally, the door design of the Tesla Semi is quite unique, clearly aimed at making it easier for drivers to get in and out. Speaking about the Semi's door design, Franz von Holzhausen explained that the Semi has a tapered front, and placing the hinge at the front would disrupt the teardrop shape, making it less aerodynamic. Therefore, they positioned the hinge at the rear, where the body is flatter, which is a sensible solution, similar to what's seen on the Rolls-Royce Silver Spur. Although Tesla respects drivers' habits, it isn't afraid to break traditional norms. For example, they eliminated the large front grille, a signature feature of diesel trucks, because electric vehicles don't require the same cooling system. Tesla also pays attention to practical details, such as serviceability. Recognizing that truck drivers sometimes bump the front corners, Tesla designed this area to be easily replaceable, reducing repair costs and downtime. Initially, the Tesla Semi's design faced skepticism from traditional drivers who considered it the ugliest thing. However, after experiencing it, they were quickly won over by the 15% fuel savings and the comfortable driving environment. The Tesla Semi is currently equipped with an 850 kilowatt-hour battery, consuming 1.7 kilowatt-hours per mile, with a verified range of 500 miles in testing so far. However, the company plans to switch to 4680 cells in the next version of the Semi. The 4680 cells are significantly larger than the LFP cells currently used, increasing energy capacity by roughly 5 times and output power by 6 times. This allows the Semi to achieve a longer range without adding many more battery cells, a particularly important factor for electric trucks, as reducing the tractor's weight increases its payload capacity. It's unclear which part of the Semi's frame Tesla will produce using the Gigapress, but it's evident that it will dramatically speed up production compared to previous methods. Elon Musk has repeatedly emphasized that Tesla will start producing around 50,000 trucks per year in 2026, which naturally raises some skepticism given the current limited number of semis. Producing 50,000 trucks annually translates to making one semi roughly every 10 minutes. With the GigaPress, this is entirely feasible, since the most complex step has always been manufacturing the frame. The GigaPress technology enables the casting of large and complex semi-truck components in a single shot, significantly reducing the welding and bolting time required in the past. This alone cuts production time from about an hour down to just a few minutes, while also improving the overall frame quality. The GigaPress can even help lower manufacturing costs, which in turn could make the semi's market price more competitive. Currently, rumors suggest the Tesla Semi Foundation series may be priced at around $250,000. We're not sure because Tesla hasn't confirmed this. It wouldn't be unreasonable given the size of the battery pack and the impressive engineering behind the big rig. On Tesla Semi website, Tesla highlights that charging with electricity costs roughly half as much per mile compared to fueling with diesel. Operators can save an estimated $150,000 in fuel costs within the first 3 years of ownership. With remote diagnostics, over-the-air software updates, and fewer moving parts that require maintenance, operators will spend less time at service centers and more time on the road. With an energy consumption of just 1.7 kilowatt-hours per mile, the operating cost comes out to about 30 cents per mile. This means that for a 6.5-mile trip, the driver spends only around $3.30 based on current electricity rates. In comparison, a typical diesel truck would need about 1 gallon of fuel to cover the same distance, and with diesel prices reaching $3.66 per gallon, the operating cost is significantly higher. But as mentioned earlier, the benefits of the Semi go beyond operating costs. In terms of maintenance, electric trucks are far simpler than their diesel counterparts. With no internal combustion engine, no complex transmission, and far fewer moving parts, the risk of breakdowns is greatly reduced. If you look around and examine how the world operates, you'll quickly realize the importance of an efficient supply chain and the timely movement of goods. While ships are widely used to transport cargo across continents and between countries, trucks remain the most efficient and most common method of moving goods over land. According to recent reports, the trucking industry handles more than 70% of all freight in the U.S. It also accounts for nearly 6% of all full-time jobs in the country and generates roughly $700 billion in annual revenue. Truck drivers consume about 12% of the total fuel used in the U.S. Although the share of freight moved by trucks varies from country to country, trucking is generally considered one of the largest and most critical industries worldwide. This makes the case for a fully electric semi-truck all the more compelling. Yet many drivers who have experienced the Tesla Semi say they never want to drive any other truck again. The Tesla Semi delivers a driving experience unlike any other Class 8 truck, not to mention its extremely low energy consumption and operating costs. For years, the global freight industry has been squeezed by a paradox: rising demand for goods, but a shrinking workforce of drivers. The core issue isn't just about wages or working conditions. It lies in the harsh realities of the job, spending dozens of hours on the road, overnight hauls, and relentless pressure to meet delivery deadlines that push drivers into exhaustion. As reflexes decline, the risk of accidents rises, creating a vicious cycle that makes many people hesitant to enter the profession. As a solution to attract younger drivers into the industry, Elon Musk revealed that Tesla is testing full self-driving on the Semi, with plans to roll it out as early as the end of this year for the Semi's second version. Once the Semi can safely operate autonomously on highways, drivers will no longer be slaves to the steering wheel. They'll be able to rest, recover their focus, and step in only for complex routes or emergency situations. This not only reduces fatigue-related accidents, but also redefines the long-haul trucking profession, transforming it from an exhausting grind into a more sustainable and appealing career. And if Musk delivers on his promise, bringing FSD to the Semi could create a dual breakthrough, addressing the global driver shortage while boosting freight efficiency with trucks that virtually never get tired. This isn't merely an upgrade, it's a structural shift that could reshape the entire logistics industry in the coming decade. This alone makes the Semi the best electric truck in the world. Although its rollout was delayed for years due to the limited production capacity at Giga Nevada, this year the Tesla Semi is expected to dominate the trucking industry with large-scale production and the integration of full self-driving. If, within the next 2 to 3 years, the Tesla Semi enters the global market, its impact will extend beyond transportation efficiency to a profound environmental footprint. According to data from the National Renewable Energy Laboratory, medium and heavy-duty trucks account for only about 4% of vehicles on U.S. roads, yet they consume more than 25% of the nation's fuel supply. This illustrates a massive imbalance between the share of vehicles and the energy they consume. In this context, a fully electric truck like the Semi could become a true game-changer. Instead of relying on diesel, a dirty energy source that directly contributes to greenhouse gas emissions, the Semi offers a cleaner, quieter, and more sustainable alternative. For every Semi that replaces a traditional diesel truck, the reduction in CO2 emissions would amount to tens of tons per year. We're talking about something with up to 3 times the energy density of what they're using now. Almost nobody knows what just happened at Tesla, but this new battery, it could completely rewrite the company's future. And it might just be Elon Musk's biggest gamble yet. How powerful is it? How cheap could it get? Let's find out. These new batteries have clearly been in the works at Tesla for a long time. Even though the company has tried to keep it under wraps, internal leaks have made it obvious that Tesla wants people to know they're doing something big to push EV battery technology forward, especially for the affordable model set to launch in the near future. What's mind-blowing is that this new battery is made from materials that are far more common and much cheaper than lithium, yet it delivers 3 times the energy density of current lithium-ion batteries. Of course, no technology is perfect from day one. There are still a few hurdles to overcome. But overall, this battery is already superior in nearly every way. And once those final challenges are solved, this won't just compete with lithium. It could replace it entirely, ending lithium's reign once and for all. Yeah, this is the Tesla A1 battery, the company's first-generation aluminum-ion battery. Put simply, aluminum-ion batteries work much like lithium-ion batteries, but instead of using lithium ions as the charge carriers, they use aluminum ions. Each aluminum-ion cell has 3 main components: a node typically made from aluminum metal, where the aluminum ions originate; cathode, built from materials such as graphene or metal oxides to store those ions; electrolyte, a liquid solution that allows aluminum ions to flow back and forth between the 2 electrodes. The key difference lies in the very nature of aluminum. Each aluminum ion carries 3 positive charges, while a lithium ion carries only 1. This means aluminum can move 3 times more energy per ion, boosting energy density without relying on rare materials or complicated manufacturing processes. In theory, this allows aluminum-ion batteries to store far more energy in the same amount of mass compared to traditional lithium-ion batteries. And now, the real-world results are starting to prove that potential. Reports suggest that the aluminum-ion battery technology Tesla is testing has already reached energy densities of over 700 watt-hours per kilogram, a figure powerful enough to completely disrupt the battery industry. To put that into perspective, if you equipped a Tesla with this battery, it could travel over 700 miles. That's about 1,126 kilometers on a single charge. Some estimates even push that number closer to 1,000 miles, around 1,600 kilometers per charge. That's a leap so massive that even the most optimistic EV enthusiasts would have a hard time believing it. Which raises one big question. How did Tesla pull off such a giant technological leap? A clear example really shows the difference. Right now, the Tesla Model 3 long-range AWD can go about 346 miles on a 79 kilowatt-hour NMC battery. And those NMC cells only have an energy density of around 180 to 200 watt-hours per kilogram. But aluminum-ion batteries, they hit about 700 watt-hours per kilogram. That's roughly 3.5 times higher. What does that mean? If you swapped out the Model 3's NMC pack for an aluminum-ion pack of the same size, that car could easily hit around 1,038 miles, over 1,600 kilometers on a single charge. That's not just pushing past today's limits. It's rewriting the standard for the entire EV industry. And while lithium-ion batteries are still widely used today, as we mentioned earlier, they haven't seen any truly groundbreaking leap in energy density for decades. Lithium-ion has been stuck at roughly 200 watt-hours per kilogram for years. Even with Tesla's most ambitious efforts, their 4680 cells, Energy density has only climbed to about 275 watt-hours per kilogram, which simply isn't enough to change the game. And that's exactly why there's room for something new, and aluminum-ion is stepping in as one of the most promising answers we've ever seen. That said, we've got to be realistic here. Sure, aluminum-ion batteries can hit 700 watt-hours per kilogram at the cell level, but once you build a full battery pack with the casing, cooling system, and all the extra hardware, that number comes down. And that's exactly why optimizing the pack's size is so critical. It's the key to keeping performance high while also cutting down production costs. So instead of that theoretical 1,000-mile range, a more practical number would be closer to 700 miles. But honestly, that's still enough to blow past anything on the market today. Now, if we look at Tesla's 4680 battery, it's still one of the most advanced battery technologies in the world. But here's the catch. This incredible battery is only showing up in high-end cars. Right now, it's basically limited to the Cybertruck, and even the cheapest variant starts at $69,990. And that raises a big question. Can Tesla actually bring this tech down to more affordable cars like the Model 3 or Model Y anytime soon? The answer, at least for now, seems to be a hard no. The reason's pretty straightforward. Lithium prices keep skyrocketing, which is driving up battery production costs like crazy. Since pretty much all of Tesla's current batteries, LFP, NMC, you name it, including the 4680, still rely heavily on lithium, using the 4680 for cheaper cars is basically a pipe dream. Elon Musk has talked up a storm about launching a compact electric car for around $25,000. But let's be real. That plan's been stuck in neutral for over 4 years. Word is it's finally dropping this November, and no shocker here, Tesla's almost definitely going with LFP batteries for that one. While an energy density of 700 watt-hours per kilogram is certainly impressive, that's not the only reason Tesla is so committed to aluminum-ion battery technology. As Elon Musk has pointed out, the bigger problem is the ever-escalating cost of lithium-ion batteries. This is largely due to the soaring demand for lithium and limited supply, which has led to overmining and ever-increasing prices. This has not only put pressure on the entire EV industry, but has also made it difficult for manufacturers like Tesla to create more affordable models for consumers.
So the price of lithium and all the raw materials and the battery cells went crazy. It doubled. The price of cells doubled. Price of lithium, I think, went up at almost fivefold or 500%. Went up crazy numbers.
Right now, Tesla's using LFP and NMC batteries for the Model 3 and Model Y, while the Cybertruck's rocking the 4680 cells. All three rely on lithium, and they also use pricey materials like nickel and cobalt. A quick Google search will tell you these are some of the most expensive materials for battery production. Even Elon Musk has admitted that the 4680 batteries are actually pricier than traditional ones, since they're packed with all three: nickel, cobalt, and lithium. So, even though the 4680 is cutting-edge tech, the cost is still a major hurdle keeping Tesla from slapping it into more affordable models. If you know anything about the metals in Earth's crust, you probably know aluminum is the most common one. It makes up about 8.13% of the entire crust. Bauxite, the main ore used to produce aluminum, is found across dozens of countries. With global reserves sitting at roughly 1.59 billion tons, aluminum is not only far easier to source than lithium, nickel, or cobalt, but it's also way less vulnerable to geopolitical risks or supply chain disruptions. And that's exactly the golden opportunity for Tesla to slash battery costs like never before. According to the data we've seen, aluminum-ion batteries could cost as little as $40 to $65 per kilowatt-hour once the tech hits full commercial scale. And that number could drop even further if Tesla ramps up large-scale production, something they've already proven they can do with their massive battery lines at the Nevada Gigafactory. Of course, Tesla doesn't regularly disclose details about production costs, and so far they've never officially revealed the actual cost of the batteries they use. However, based on independent analyses, it's estimated that batteries typically account for about 25 to 40% of a Tesla's total production cost, depending on the battery type, vehicle model, and specific configuration. For example, with the Tesla Model Y priced between $45,000 and $60,000, its battery pack ranges from 67 to a tantadue kWh, applying an average NMC battery cost of around $139 per kilowatt hour. The battery pack's cost would be approximately $9,300 to $11,400, equivalent to 19 to 25% of the vehicle's total value. However, if replaced with aluminum-ion batteries costing only $40 to $65 per kilowatt hour, this figure would drop significantly to just $2,700 to $3,000, $5,300. This means Tesla could substantially reduce selling prices, creating a real opportunity to bring affordable EVs to more people. When Elon Musk chooses to invest in a new battery technology, performance and energy density are always top priorities. However, the most critical factor is scalability. No matter how powerful a battery is, if it's too expensive and only suitable for luxury vehicles, it won't drive real change. That's why aluminum-ion batteries are expected not only to deliver superior performance, but also to solve the production cost challenge, a key factor in enabling Tesla to lower electric vehicle prices and shed its reputation as a company that only sells EVs for the wealthy. Beyond that, aluminum-ion batteries have an advantage that even the most advanced lithium-ion batteries can't match: charging speed. While a modern lithium-ion battery takes at least 20 to 30 minutes to charge to 80%, aluminum-ion batteries can reach a full charge in just 5 minutes, and notably they do so without overheating. This could eliminate one of the biggest barriers preventing wider adoption of electric vehicles. The ultra-fast charging capability of aluminum-ion batteries stems from their fundamental properties. Aluminum ions move through the electrolyte 3 times faster than lithium ions. As a result, charging is not only faster but also maintains optimal performance without stressing the battery's structure. More importantly, these batteries offer superior thermal management, effectively addressing the overheating issue, a critical weakness of traditional lithium-ion batteries. Thanks to these advantages, aluminum-ion batteries are not only faster to charge but also safer and more durable over the long term. Additionally, one of the chronic diseases of lithium-ion batteries, the formation of metal dendrite crystals, is virtually non-existent in aluminum-ion batteries. Dendrites are metal crystals that form during charging, potentially piercing the separator, damaging the battery's structure, and causing serious issues like reduced performance or even fires and explosions. With aluminum-ion batteries, the release of aluminum ions occurs much more uniformly and stably, nearly eliminating the risk of dendrite formation. Studies from reputable institutions like Stanford University have shown that these batteries can withstand tens of thousands of charge-discharge cycles without this issue, a massive leap forward compared to traditional lithium-ion batteries. While conventional lithium-ion batteries typically endure around 2,000 charge cycles before dropping to 80% capacity, equivalent to 4 to 8 years of daily use, some independent studies suggest aluminum-ion batteries can achieve up to 15,000 cycles. This means that with proper use and maintenance, an aluminum-ion battery could last up to 35 years, a true game-changer compared to current battery technologies. The reason for this remarkable durability lies in the physical and chemical properties of aluminum. Physically, aluminum is an exceptionally robust material, widely trusted in modern car frames for its strength and resistance to deformation. Chemically, aluminum is far more stable than lithium. While lithium readily reacts with oxygen and water, leading to material degradation over time, aluminum forms a natural oxide layer when exposed to the environment. This oxide layer acts as a shield, preventing corrosion and maintaining the stability of the anode, thereby extending the battery's lifespan far beyond existing technologies. This is the key point. Tesla isn't just developing a battery that charges faster. It's creating one durable enough to potentially outlast the electric vehicle itself, making battery replacement a thing of the past. But that's not all. Another persistent issue with lithium-ion batteries is the risk of fire and explosion. Lithium batteries can ignite if impacted or overcharged, and the resulting smoke is not only toxic, but also extremely difficult to extinguish. Despite years of research and improvements, this risk has not been entirely eliminated. In contrast, aluminum-ion batteries are nearly immune to this danger due to their stable chemical properties and superior heat resistance, setting a new safety standard for the EV industry. Additionally, aluminum-ion batteries offer a strategic advantage: superior recyclability. Aluminum is the most abundant metal on Earth, and if this technology is widely adopted, it could significantly reduce reliance on expensive and hard-to-mine metals like lithium, nickel, or cobalt. Laboratory experiments have already shown that up to 80% of aluminum fluoride salts can be recovered, with expectations of even higher rates at industrial scale. Notably, the solid aluminum foil from these batteries can be reused almost directly after cleaning, making aluminum-ion batteries one of the most sustainable and environmentally friendly solutions the industry has ever seen. However, no technology is perfect from the start, and aluminum-ion batteries are no exception. A notable challenge is their reduced performance in low-temperature environments, which currently limits their use in colder climates. Nevertheless, this is not an insurmountable barrier. Leading research teams worldwide, including Tesla, are intensely focused on addressing this issue to ensure that aluminum-ion batteries not only excel in performance, but are also ready for all real-world conditions. Currently, aluminum-ion batteries have not been widely publicized and are rarely mentioned in mainstream media. However, if Tesla can successfully commercialize A1 battery cells and integrate them into more affordable vehicle models, it would not only be a technological breakthrough, but also a game-changer for the entire electric vehicle industry. According to internal sources, Tesla plans to produce all aluminum-ion batteries in the U.S. at a new expanded facility adjacent to Giga, Nevada. The production line is expected to begin operations by the end of this year, once all equipment is installed and fully calibrated. In theory, the lifespan of aluminum-ion batteries is truly impressive. No battery lasts forever, but with the potential to achieve up to 15,000 charge cycles, aluminum-ion batteries could last 35 years or more, a figure that lithium-ion batteries cannot come close to matching. This makes them an ideal choice not only for electric vehicles but also for large-scale energy storage systems. More importantly, in terms of cost, researchers believe that when mass-produced, the price of aluminum-ion batteries could be comparable to, or even lower than, current lithium iron phosphate batteries, a possibility that was once considered nearly impossible. Over the past 2 years, lithium prices have been a roller coaster, with brief dips followed by sharp spikes. This year, they surged to $9,200 per ton. The issue isn't just the cost, but also the scarcity. Global lithium reserves are estimated at around 89 million tons, nearly 18 times less than aluminum. More concerning, the majority of these reserves are concentrated in just 4 countries. China holds about 16.5%, with the rest primarily in the lithium triangle of Chile, Bolivia, and Argentina. With such concentrated supply, lithium prices are not only high, but also vulnerable to geopolitical factors. While Apple once dreamed of building a self-driving car to outpace Tesla, Elon Musk has long been nurturing the Tesla PiPhone project, a groundbreaking smartphone with features and designs unlike anything we've ever seen before. We mean truly different. The Tesla PiPhone is scheduled for release next year, and Elon Musk believes it will directly compete with Apple's iPhone 17, set to launch at the end of this year. We're not sure who will come out on top, but leaks of the Tesla PiPhone's design and features have already surfaced. What shocked us most was the integration of free Starlink technology, unlocking the era of smartphones with unlimited global internet. So, what exactly does the Tesla PiPhone offer, and what is Elon Musk's ultimate ambition with this project? Let's find out now. First, let's explore whether the Tesla phone can actually compete with the Apple iPhone. There's no denying that the iPhone has transformed the way humanity communicates, entertains, and works. Since 2007, every generation of iPhone, iPad, and MacBook has been tied to major milestones in mobile technology. But after nearly 2 decades, what was once a symbol of innovation is now facing growing accusations, being conservative and lacking breakthroughs. The iPhone 16, launched in September 2024, is a prime example. Although Apple pulled off another massive marketing campaign, the general sentiment among the community was disappointment. Elon Musk even mocked it on X, saying, "It's hard to tell the difference without looking closely." To him, the iPhone 16 is nothing more than 2 extra buttons and a new color, hardly worthy of the tens of billions of dollars Apple spends on R&D each year. He also wrote on X, "For only $50 billion in R&D, what a bargain." This reveals a paradox. The newer the iPhone, the harder it is to notice the difference. You spend thousands of dollars on a new phone, yet most people won't even realize you upgraded because it looks almost identical to the previous generation. However, the letdown of the iPhone 16 has only fueled curiosity about the upcoming iPhone 17. Can Apple reclaim its former glory, or will they continue releasing phones with nearly unchanged designs and ever-rising prices? Amid this anticipation, several reports suggest that the iPhone 17 might actually become the worst phone in the company's history. To achieve an ultra-thin design of just 5.5 millimeters or 0.22 inches, Apple has also had to shrink the battery. The iPhone 17 Air is rumored to carry a super slim battery of only about 2,800 to 2,900 mAh, significantly less than the iPhone 16 Pro's 3,582 mAh or the Galaxy S25 Edge's 3,900 mAh. As some have put it, it's a step backward wrapped in a beautiful shell. And that's not all. The iPhone 17's performance and RAM are expected to see little to no improvement compared to the iPhone 16, despite a higher price tag. It's clear that Apple is willing to sacrifice performance for a slimmer design. The iPhone 17 could end up being the thinnest phone the company has ever made, which will no doubt appeal to younger consumers who love flashy looks. Meanwhile, Tesla's Pi phone is taking a completely different approach. Instead of obsessing over thinness, Musk is focusing on durability and practicality, much like most other Tesla products. According to company sources, the Pi phone's body isn't built the usual way. It's made from a titanium alloy, the same material used in SpaceX spacecraft, many times stronger than aluminum yet lighter than steel. What really surprised us is that while Apple only recently started using grade 5 titanium in the iPhone 15, Elon Musk has already demanded grade 6 titanium for his phone. Reportedly, he even reassigned a few experienced SpaceX engineers to Tesla solely to help with the titanium crafting process. Internal tests show that while an iPhone can easily shatter when dropped from 6.5 feet, the Pi phone can survive a 13-feet fall onto concrete with nothing more than a few minor scratches. Although we're pretty excited about the iPhone 17's ultra-slim 0.22-inch design, since at the very least it feels lighter in the hand and less tiring to hold over long periods, we don't see this as a real advantage when it comes to long-term usability. The truth is, an overly thin device will quickly reveal its weaknesses after just a few months of use. The phone becomes more vulnerable to damage or screen failures, even from minor bumps. A thinner build also means the back surface is more exposed to heat from the battery pack, making the device heat up more easily, which disrupts the user experience. On top of that, replacing iPhone components is far from cheap. We believe that for older users or those on a tighter budget, stability and durability matter far more than flashy looks. That's why the Tesla Pi phone stands out. It can meet the needs of anyone who values a rugged, long-lasting device, even if it may not look quite as stylish as an iPhone. So here's the big question. Do you prioritize durability or sleek design? Drop a comment below. About dimensions, the Tesla Pi phone measures 5.72 inches tall, 2.75 inches wide, and 0.29 inches thick. To prevent slipping, Tesla is said to have built in an exclusive feature called the Smart Grip Sensor, integrated into the frame. When it detects that the user is holding the phone loosely or is about to drop it, the device vibrates as a warning. For older users with shaky hands, we think this small detail could be extremely helpful. Leaks also suggest that the Tesla Pi phone will feature a 6.9-inch AMOLED display, protected by a nanoshield glass layer, which is about 25% stronger than Apple's ceramic shield. It's still unclear whether the screen will reach true 4K resolution, but with AMOLED technology, we can at least expect ultra-sharp visuals, vibrant colors, and high contrast, perfect for movies, gaming, or music. On top of that, the display reportedly supports HDR10+ Dolby Vision and True Tone technology, which automatically adjusts color balance based on ambient lighting for a more comfortable and immersive viewing experience in any condition. The Tesla Pi phone is also confirmed to include both an under-display fingerprint sensor and 3D facial recognition technology, features already found on the iPhone. However, what surprised us just as much was the incredibly impressive water resistance that Tesla has equipped their phone with. The Tesla Pi phone is confirmed to feature IP68 water resistance, similar to its competitors. With the IP68 standard, the device can withstand submersion in about 5 feet of water for 30 minutes. That said, Because the Pi phone is meticulously crafted with a body made from grade 6 titanium alloy, it can endure even longer than the iPhone's limits. Tesla didn't just focus on durability, they also invested heavily in the camera system, which we believe is what truly sets it apart. Although Elon Musk has yet to confirm, reliable sources suggest Tesla will launch 3 versions of the Pi phone: the standard model with 3 cameras, the Plus model with 4 cameras, and the high-end version possibly boasting up to 5. This could make the Tesla phone easier to distinguish from the iPhone. The highlight is a 50-megapixel main sensor, outperforming the iPhone 16 Pro Max's 48-megapixel, paired with 3 times optical zoom and a high-powered LED flash to ensure sharp images in any lighting condition. Notably, each device features a subtly glowing Tesla logo on the back, not only serving as an iconic brand mark, but also functioning as an auxiliary sensor that supports the camera system. This is how Tesla transforms an aesthetic design element into a functional part of its tech ecosystem, both stylish and practical. If the iPhone has long been haunted by short battery life, then it's clear the Tesla Pi phone is here to solve that problem. From what we've learned, the Tesla phone will come with a 6,125 mAh battery, far surpassing the iPhone 16 Pro Max's 4,676 mAh and nearly doubling the expected 2,800 mAh capacity on the upcoming iPhone 17 Air. More importantly, Tesla isn't using the traditional lithium-ion battery. Instead, they are pioneering aluminum-ion battery technology, developed in-house specifically for smartphones. This battery offers outstanding advantages: double the energy density, lower heat generation, much greater safety, and an almost complete elimination of fire or explosion risks. Thanks to this, the Pi phone maintains a slim and lightweight design while delivering 3 to 4 days on a single charge, compared to the iPhone's typical 1 to 2 days. The Tesla Pi phone also supports smart fast charging, allowing it to go from 10% to 80% in just 35 minutes. While this speed isn't groundbreaking, Elon Musk has explained that Tesla won't join the super-fast charging race seen in Android phones, because ultra-high charging speeds often degrade battery health quickly. This strategy highlights Tesla's focus on long-term battery longevity above all else. Of course, even with impressive battery life, there are still situations where users might travel long distances and forget their charger. Tesla has thought of that too. According to multiple leaks, the Pi phone may integrate an ultra-thin solar panel on the back. This solution isn't designed to fully replace traditional charging, but it can provide a few extra percent of battery in emergencies, such as when traveling, hiking, or staying in remote areas. Clearly, carrying a phone like this would make any journey feel reassuring. With their experience in solar roof and Powerwall, Tesla knows how to harness solar energy in a streamlined, efficient way without significantly increasing production costs. This is a major differentiator. Instead of just chasing specs, Tesla is building a mobile energy ecosystem, turning the Pi phone into a device that's not only smart, but also energy autonomous, aligned with the global sustainability philosophy that Elon Musk pursues. What makes the Tesla Pi phone stand out isn't just the hardware, but also the operating system. Rather than relying on iOS or Android, the Pi phone runs on XOS, a proprietary platform Tesla has quietly been developing for years. While built on a Linux foundation, XOS has been almost entirely rewritten, giving Tesla full control over everything: core architecture, user interface, security, and AI. Where iOS and Android are often tied to user data collection for advertising purposes, XOS is designed with the opposite philosophy: maximum security and deep personalization. The operating system can learn user habits and optimize the experience for each individual, while still committing to never turning user data into a commercial goldmine. This is how Tesla positions the Pi phone as a true technology device, not an advertising tool. The standout feature of XOS lies in its seamless integration with Tesla's entire ecosystem. With just a Pi phone, users can unlock their Tesla, cool the cabin before getting in, or even summon an autonomous car to pick them up. Going further, the Pi phone could command the Optimus robot to clean the house or monitor the Powerwall energy storage system. It could serve as the central control hub for the entire Tesla universe, a level of integration that iPhone or Android simply can't match. While the iPhone still requires downloading ChatGPT from the App Store, the Pi phone integrates Grok AI directly into XOS. This allows the device to respond faster and even handle some tasks offline. Grok isn't just a virtual assistant, it's a gateway for users to access the full Tesla ecosystem, from electric cars and solar energy to the Optimus robot. This is a completely different kind of experience. The Tesla Pi phone won't just be a smartphone, It could also serve as a direct gateway to the Starlink satellite network, potentially even providing free internet. If realized, this would be a historic pivot, permanently reshaping the global telecommunications industry. Currently, Starlink has over 6,000 operational satellites orbiting Earth, with plans to expand to 40,000, creating a space-based internet grid entirely independent of terrestrial infrastructure. With the Pi phone, users could maintain a 250 megabits per second connection anywhere, from the Sahara Desert and Antarctic research stations to a remote island in the middle of the Pacific. No cell towers, no more dead zones. In emergencies, the Pi phone could even become a genuine survival tool. While global carriers still rake in hundreds of billions of dollars each year from selling SIM cards and data plans, if Tesla truly offers free satellite internet bundled with the Pi phone, it would be a direct blow to an entire massive industry. Of course, skepticism is understandable. How could Elon Musk possibly make free a service that costs tens of billions of dollars to deploy? In reality, the operating costs of satellites after launch are relatively low. Musk could apply a cross-subsidy strategy, using profits from EVs, energy storage, and AI to offset internet services. Another possible scenario is a two-tier model, a free basic plan for everyone, and a premium paid plan for those who need higher bandwidth or advanced features. When leaks suggested that the Tesla Pi phone would start at just $799, the tech community couldn't hide its surprise. A device rumored to feature technologies even more advanced than the iPhone Pro Max, yet priced far more accessible, seemed almost illogical at first glance. But looking back at how Elon Musk positioned the Model 3, the picture becomes clearer. Sacrifice margins to quickly expand market share and then monetize the surrounding ecosystem. In reality, Tesla's biggest challenge isn't technology, which is already their strength, from batteries and materials to large-scale manufacturing, but user habits. Convincing millions of people to abandon iOS or Android isn't just a matter of software, but also psychology. The fear of switching operating systems and losing access to familiar apps. Musk knows that to break this inertia, pricing must serve as the lever. And $799 hits the sweet spot. Cheaper than a premium iPhone, yet still positioned as a high-end device, enough for users to feel they're not losing anything by trying. Tesla also has an advantage Apple and Samsung struggle to match: mastery of supply chain optimization and direct-to-consumer sales. With experience producing millions of electric vehicles, Tesla is already adept at driving costs down to the bare minimum. They also don't need to pour billions into traditional marketing, just as they don't for their EVs. Customers will come on their own once they understand the product's quality. Most importantly, Tesla isn't betting on direct profits from the phone itself. Instead, the Pi phone is designed as a ticket of entry into a much larger ecosystem: Starlink satellite internet, Grok AI, EV management, Powerwall energy storage, and the humanoid Optimus robot. For $799, users aren't just buying a smartphone, they're buying access to the entire technology universe Elon Musk is building. Ultimately, the Tesla Pi phone isn't launching just to compete with the iPhone, it's here to change the rules of the game. So, what's your take on Tesla entering the smartphone market? Can they compete with giants like Apple and Samsung? If you could add one dream feature to the Tesla Pi phone, what would it be? That's a wrap for our Tesla Pi phone discussion. Drop your answers in the comments. We can't wait to read them. If you loved this video, smash that like button, subscribe, and ring the bell for more tech content. Share this with your friends to keep the hype alive, and we'll catch you in the next one. Goodbye.